managing our class. I would like you to stop your videos. You put off your camera and your microphone so that we don't have any interruptions. So we are beginning our class. Are you seeing anything on your screen? Yes. Miss Pamela, what are you seeing on your screen? Good. So I hope all of you are in this class. No one has joined us from another world who is not taking electrical and electronic engineering. Right? Is there anyone who is misplaced? So it means no one is misplaced. So we can begin our class, and I want to remind ourselves that in our previous class we did some indices and logarithms, operations on indices and logarithms. And now we're going to apply some concepts in that topic, in the previous topic, to our new topic. And our new topic today is, you can allow me to add some students who are joining us. All right. Um, our new topic is binomial expansion. That's our new topic today is binomial expansion. And hope everyone has seen our new topic. Victor, are you seeing anything on your screen?
Yes,
What are you seeing?
binomial expansion topic for today.
All right. So by the end of this lesson, I want each and every one of us to be able to define a binomial expression, expand binomial expressions. Now, on definition of binomial expressions, who can read for us that definition for binomial expression? Geoffrey, can you read for us? Good. That is the definition of a binomial expression. So from the word binomial pi there, let me use my highlighter here. So this pi means 2, and the norm from binomial means term. So an expression of two terms combined together by either plus or a minus is what we call as binomial expression. So in general, a plus b raised to some power n, where n is a set of numbers. Real numbers can be negative numbers, positive numbers, or fractions. So this is the general way we can express a binomial expression. Now, algebraic expansion. Who can read for us what's on the screen about algebraic expansion? Frank? Yes, Frank? You can put on your microphone, Frank. Yes, Cosmas, can you read? Very good. When we you can put off your microphone. When we remove these brackets, we then say we have expanded our algebraic binomial expression. Now let's look at some expansion, and there is a very important statement there on our screen that reads, in an binomial expansion, there is removing of brackets, and we make a new series of terms. Now let's consider that table. There is a table on your screen. There is a table on your screen. And I want one of you, Pamela, can you read us those expressions and their expansions? Good, that's very nice. So when we expand our expressions, we get an expansion of terms without brackets, as you can see. And when you look at this area where I'm highlighting, n is 0, but the number of terms is 1. N is 1, and the number of terms is 2. This one implies that we increase n by 1 to get the number of terms. Again, we note that down there, that there are no brackets after we've done an expansion. Good. So let's consider an expansion of A plus B. You can allow me to add some students here who are joining us late. They're joining us late to our class. Good. So this is Nixie. Yes, Nix, come to our class. Yes, join us. So that is Nixie is joining us. So you can see from our expansion of A plus B to power 1, by definition of expansion, we say that we remove the brackets or we open the brackets. So what do we obtain when we expand A plus B to power 1? We obtain A plus B. So from there you can see A is our first term and B is our second term after we expand A plus B to power 1. Let's consider an expansion of A plus B to power 3. When we expand that one, we obtain a series of terms. Actually, that series of terms contains 4 terms. We said that if n, we said that if n, as you can see, is 3, then the number of terms will be 4. That's what we already said there. So we obtain that. So when you look at our expansion there, you can see the first term, the second term, the third term, and the fourth term in that order. Good. So still we are considering our expansion. You can see we had 1, 3, 3, 1. The ones in red. Those ones we call, they are known as coefficients. Those ones, they are known as coefficients of the terms, and they're according to the terms. They're respective to the terms. So these coefficients can be obtained from Pascal's triangle. They can be obtained from Pascal's triangle. We also note that, number 1, Victor, can you read for us the first note? Hapo chini imeandikwa note. The power of.
So, the powers of A are decreasing.
Yes. Continue reading.
A is to A is to when A is to zero.
Good. Cosmas, can you read the next note? Geoffrey, is Geoffrey around? Can you read for us? Can you read the second note? Good, good, good. So we were reading the second note that while for B are increasing. So we note that the powers of A are decreasing while the powers of B are increasing. Good. Let's now look at that task. We have a task there, and we want to find an expansion for x plus y to power 2, and then we identify the terms and the coefficients. The solution, we find that that expression is similar to x plus y. You open and close those brackets into x plus y. Open and close the brackets. So then now we can expand. We take this x, the x here, and then you multiply what is in the second bracket as we've done here. So we have a plus here. Then you add this plus here. Then there is a y. So this y, you multiply by what's in the second bracket. Like that. So next, what do we get? So we open these brackets. We get x squared plus xy. We have another xy plus y squared, as you've seen there. You can see the ones that are highlighted in red here, they are like terms. So therefore, this one means that we have x squared plus 2xy plus y squared. Very good. This method of expanding is known as by polynomial multiplication. That is by polynomial multiplication. Now we have another expansion there, x plus y to the power of 3. We want to identify the terms and the coefficients after we expand. So remember, x plus y to power 3 is the same as you find the x plus y squared as we did in the previous example. And then you multiply to x plus y so that we make to a power of 3. So n here is equals to 3. So we had done our first expansion. We had reached here. This is where we reached. This is our first expansion of the first two, and we had done it. Now this one, you multiply by x plus y here, as we've done here. This is our step 2. Good. So when we expand, we'll end up getting to x cubed plus 3x squared y plus 3xy squared plus y cubed. Now, class, I'm asking a question. on the first, second, third, and fourth terms. So I want you to read for me the first, second, and third terms in that order. Who can read for us? Is Misati around? Can Misati read for us? Yes, Abaddon, can you be where there is a network so that you read for us? Whoever is on a network, you can read for us. Is Victor around? Can you read for us the terms here? The first term is? Mm. Yes, yes, yes. Good, good, good. So those are the terms after we expand that expression. So we have a task there, and I want you during your free time, you expand 2x plus 3y to power 3 in descending powers of x. You identify the terms, positions, and their respective coefficients. After which you do that work on a clean foolscap, you hand in for marking. So in summary, this is what we've learned today. Who can go through what we've learned today?
Okay. And we've learned that zero binomial expression is expressed as a into b raised to power n.
Yes, another person, what have we learned? Pamela, what have we learned today? Yes, what have we learned? Yes, Victor, what have we learned?
Okay, well, mm, expansion. We are expanding we use the brackets in polynomial multiplication.
Good, that's very nice. Now, next time when we meet, we shall discuss coefficients from Pascal's triangle. You can have a nice time.